Hello students, in the P block elements lesson, the next property we are going to see is inert pair effect. It's very important. It will be useful for any competitive examination, or even in your 12th standard it can be asked in the compulsory question part. So pay attention and learn well. Okay va? So the property we are going to see now is inert pair effect. Students, can you please tell me the meaning of the word inert? What is called as inert? Inert na mandam, which means unreactive. Okay, so that is inert. Then pair means two objects. Okay, so that is called as inert pair effect. In this place the term pair is used to represent a pair of electrons. Okay va, ரெண்டு electrons குறிக்கிறதுக்காக it is the term pair is used, inert pair effect. So an outline of this concept is, out of the electrons present in the valence shell of P block elements உடைய valence shell உள்ள electronsல two electrons will be reluctant, will be unreactive, will be inert. புரியுதா? மொத்தம் இருக்கிற electronsல s ஆர்பிட்டாலில் இருக்கிற ரெண்டு electrons வந்து they will be unreactive. Unreactive means they won't be involve themselves in bonding. So that effect is called as inert pair effect. Okay, so what is inert pair effect? The reluctant in bonding of the pair of electrons present in the s orbital, that is called as inert pair effect. Let us see this. Okay, in this concept each and every word is important. Okay, this property, this inert pair effect will be shown only by P block elements. This property will not be shown by either S, then D or F block elements. It's a special property of P block elements. Okay, and it is shown by heavier post transition metals. What is the term post? Post, pre means before, post means after. Okay, heavier post transition metals, which means next to D block elements. In D block we have three series, 3D series, 4D series and 5D series. No? When 3D series complete, the next element is called as post transition element, because D block elements also have another name, that is transition elements. Then when 4D series completed, the next element is called as post transition elements. Likewise, when 5D series is complete, the next element is called as post transition element. Post transition elements of group number 13, 14, 15 and 16. Those elements can show this inert pair effect. Okay, so it is a special property of P block elements. It can be shown only by heavier post transition metals of the group 13, 14, 15 and 16. Okay va? And this term, this inert pair effect, it is related to oxidation state. Okay, so we know oxidation state is equal to the number of electrons lost by a particular atom. Okay va? And this oxidation state is directly related with the valence electrons. Valence electrons means we know the number of electrons present in the outermost shell. Okay va? So here, to remember, the oxidation states of alkali and alkaline earth metals are given, that we have studied in 11th standard. What is the general oxidation state of alkali metals? Since they possess one electron in their outermost shell, their oxidation state will be +1. While bonding, they can lose that one electron and they will become +1 oxidation state. Likewise, alkaline earth metals, they possess two valence electrons. So when bonding occurs, they can lose those two electrons and they will become +2 oxidation state. And now we are going to see the oxidation states of P block elements, that also we have completed in the former videos. Okay, so the P block elements can show two different oxidation states. Okay, so one is called as variable oxidation state. It can be from +1, +2, +3 up to +7. They can show variable oxidation states. And another oxidation state is called as group oxidation state. Can you remember what is called as group oxidation state? Group oxidation state means it will be equal to the number of valence electrons present in the element. If we take boron family, the number of valence electrons will be 3, so that their group oxidation state will be +3. If we take carbon family, the number of valence electrons will be 4, so that their group oxidation state will be plus 4. Likewise, nitrogen family plus 5, since they possess 5 valence electrons. Then oxygen family plus 6, since they possess 6 valence electrons. Okay, likewise, the group oxidation state is equal to the number of valence electrons present in the particular atom. Okay, okay. Let us come to our concept, inert pair effect. In case of the heavier post-transition metals, for this the explanation I have given you already. In the case of heavier post-transition elements, the most stable oxidation state. We have seen that the p block elements are showing variable oxidation states. No, p block elements variable oxidation state, +1 irukkalam, +2 irukkalam, +3 irukkalam. So in that, the most stable oxidation state, out of those variable oxidation states, the most stable state is 2 less than the group oxidation state. Okay, can you able to understand, students? இப்போ boron family எடுத்துட்டோம்னா the number of valence electrons வந்து 3, so that their group oxidation state should be +3. அதனுடைய group oxidation state +3 இருக்கணும். பட் அதில் most stable எதுன்னு பார்த்தோம் அப்படின்னா +1. அந்த +3 குரூப் ஆக்சிடேஷன் ஸ்டேட்லேருந்து 2 மைனஸ் பண்ணினா வர்றது தான் மோஸ்ட் ஸ்டேபிள் ஆக்சிடேஷன் ஸ்டேட்டாக இருக்கும். தட் இஸ் கால்ட் அஸ் inert pair effect. The most stable oxidation state is 2. 2 means here the number 2 number less than the group oxidation state, and the reluctance to exhibit the group oxidation state. Group oxidation state exhibit பண்றதுக்கு பதிலா அதுல இருந்து 2 நம்பர் கழிச்சு அந்த oxidation state exhibit பண்றதுக்கு பேர் தான் inert pair effect. The reason we are going to see, and also the periodicity. இது மேல இருந்து குரூப்ல மேல இருந்து கீழ வரும்போது எந்த மாதிரி வேரி ஆகுது, that also we are going to see. Okay, let us take the example boron family. Boron family general electronic configuration is ns2np1. Okay, and the number of valence electrons are 3. That also we know. Then expected group oxidation state. What is group oxidation state? The number of electrons present in the outermost shell. Here 3 electrons, no? So the expected group oxidation state is +3. Okay, and this state will be common for boron and aluminium. Boron and aluminium +3 the most stable state. When we come more than beyond aluminium, the what is there? The post transition elements. ஏன்னா போரானா அலுமினியம் போஸ்ட் ட்ரான்சிஷன் எலிமெண்ட்ஸ் கிடையாது, அதுக்கப்புறம் உள்ள எலிமெண்ட்ஸ் தான் போஸ்ட் ட்ரான்சிஷன் எலிமெண்ட்ஸ். ஓகேவா? ஸோ +3 ஸ்டேட் இஸ் மோஸ்ட் ஸ்டேபிள் ஃபார் போரான் அண்ட் அலுமினியம். தென் ஃபார் gallium, thallium and indium, the +3 is not the observed oxidation state. ஓகேவா? But when we move from top to bottom, there is an increasing tendency to have +1 oxidation state rather than the group oxidation state. Is it clear, students? Boranukum aluminium +3 தான் common oxidation state. But in the case of post transition elements, மேலேருந்து கீழே வரும்போது +3க்கு பதிலாக instead of +3, the atoms prefer to show +1 oxidation state. Okay, now we are going to see a comparative study between aluminium and thallium. This is very important question. It can be asked in compulsory. Okay, aluminium 3+ is more stable than aluminium +1, whereas thallium +1 is more stable than thallium +3. Okay, so thallium in this state la romba more stable இருக்குது. Thallium is highly stable in +1, that is the lower oxidation state, due to what? Due to inert pair effect. இதில் உங்களுக்கு ஒரு question கேட்கலாம். Out of thallium +1 and thallium +3, which is the most stable state? அப்படின்னு கேட்டாங்கன்னா என்ன சொல்லணும்? thallium +1 is the most stable state because of inert pair effect. இந்த பார்ட்ல இருந்து கண்டிப்பாக கம்பல்சரி கொஸ்டின் எதிர்பார்க்கலாம். ஸோ உங்களுக்கு ஏதாவது டவுட் இருந்துச்சுன்னா இமீடியட்டாக யூ கேன் அப்ரோச் மீ அண்ட் யூ கேன் கிளாரிஃபை யுவர் டவுட்ஸ். கேன் யூ ஏபிள் டு அண்டர்ஸ்டாண்ட்? அவுட் ஆஃப் Tl3+, thallium 3+ and thallium +1, which is most stable? Thallium +1 is most stable. That is due to what? Due to inert pair effect. Okay, so this is the definition for inert pair effect. This was the question asked in the last year, 2018 public examination. What is inert pair effect? So if they ask means what we have to write this is a special property shown by p block elements. That is very essential. Okay, and then definition. In heavier post transition metals, the outer s electrons, boron family பார்த்தீங்கன்னா ns2 np1, அதான் general configuration. போரானுக்கு அலுமினியத்துக்கும் +3 state சொல்லியாச்சு. So we need not disturb them. Then when we come to gallium, thallium and indium, let us take thallium. Okay, so at that time thallium also will be possessing have a tendency to remain inert. அந்த s ஆர்பிட்டாலில் உள்ள 2 எலக்ட்ரான் வந்து பாண்டிங்கில் இன்வால்வ் ஆகாமல் they will become inert. and reluctance to take part in the bonding, that is known as inert pair effect. Okay, the effect is also observed in group number 14, 15 and 16. Can you able to understand, students? நம்ம பி பிளாக் எலிமெண்ட்ஸுடைய ஜென்ரல் எலக்ட்ரானிக் கான்ஃபிகரேஷனே NS2 NP126 தான். அதில் மேலே டாப்பில் உள்ள எலிமெண்ட்ஸ் பிரச்சனை இல்லை, மேலேருந்து கீழே வரும்போது அந்த NS ஆர்பிட்டாலில் உள்ள 2 எலக்ட்ரான் வந்து பாண்டிங்கில் இன்வால்வ் ஆகாமல் தே ரிமைன் இன்னட். அதனால் பி ஆர்பிட்டாலில் உள்ள எலக்ட்ரான் மட்டும்தான் லாஸ் ஆகும். ஸோ தே won't show group oxidation state. Instead, the true number less than the group oxidation state. That is called as inert pair effect. Okay, students, go through this video and learn well. For doubts, you can approach me. Thank you.